Alright, welcome back to today's studies. We are going to talk about rigid motion. Rigid motion. So let's see, this is our Cartesian plane. We have a shape here, and I'm bringing the shape to this side. You can see here, I am just changing the position. It is here at this at one position, and I'm bringing it to the other side. So here I am just changing the position without changing the shape. It's the same figure. So when you talk of rigid motion, it simply means changing the position of an object without changing the shape. So I've changed the position from this side to this side. And there are three ways that we can change the position of an object without changing its shape. The first one is what? Translation. And the second is we have rotation. We can rotate it, or we can what? Reflect it. Reflection. So if it is here, I can turn it this way, I can bring it this way. So I have reflecting it. So we are going to start with reflection. Reflection. As you know, mathematics, we solve more and we talk less. So here, reflection, we are just moving an object in a straight way for the object to what? Look this. So here, when we talk of translation, we always translate a point by what? A vector. Translate a point by a vector. So let's consider some formulas that we are going to use. So we are saying we have an image that we will get equals what? A point plus vector. Image equal point plus vector. So we always say I equal P plus V. So here sometimes they can give you the image and ask you to what? Find a point and a vector. So here, let's make point a subject. You can see that our point here is what? Image minus what? Vector. And likewise, our vector is also going to be, we are taking P to the other side, image minus what? The point. So this is our equation 1. This can be our equation 2. This will be our equation 3. So that is what? Translation. So let's take a quick example. Let's translate this point. Translate a point to 3 by a vector, or through a vector to negative 4. Look at how we write the vector. This is vector. So this is how we write it, and this is what? In coordinate. We call this one coordinate. Okay. So here we are just translating what? This point through the vector. So here we just want to find the image. So the image. So we are finding the image of this point, right? 2, 3 through this vector. So as I told you, image equal what? Point plus vector. So the point is 2, 3 plus the vector 2, negative 4. So this one 2 plus, we are going to get 4. 3 plus negative 1 is 3 minus 4. So you are going to get negative 1. So this is the image of what? The point. This is image of the point. Let's take another example so that you will understand it very well. We are taking another example. We are taking another example here. Okay, so a minute. Okay, let's see this question. A triangle ABC with vertices A, -1 and -1, B, 3, 4, and C, 2 and what? 1. So find the image of the triangle by the vector -1, -2, such that A maps to A1, B maps to B1, and C maps to what? C1. So this is just telling us from A to the image of A, from B to the image of B, from C to the image of what? C. So here, we are finding the image of the triangle. So you just have to quote your image equal your point plus your what? Your vector. So the point, let's take the first one. So you take A and you are corresponding A to A1. So this is A. So the point for A is -1 and -1. And the vector, we are using the same vector. So we are going to get what? -1 plus -1 is -2. You are owing 1 CD. You are also owing another 1 CD. When you add it, you owe 2. -1 plus -2 is -3. Good. So this is A, and it maps to the image of what? A. And so you can say A1, write it in coordinate form, -2, -3. Is that okay? Now let's try B. Let's do B here. B maps to what? B1. So this is going to give us the point plus the vector. So the point is what? Point B is 3, 4 plus, I'm changing the method, -1, -2. We are adding them. So it's the same thing, just that this time around I am bringing it down. So 3 plus -1 is what? 2. 4 plus -2 is like 4 minus 2. You are going to get 2, right? So this B maps to the image of B1. So B1 is 2 and what? 2. All right, let's find the other coordinates. Let's find the other coordinate, which is C. So you know we are finding C maps to what? C1. So it's the point plus vector. Our image is still the same. So the point C is 2, 1, and the vector is -1, -2. If I'm correct, yes. So 2 plus -1 is like 2 minus 1, and it's 1. 1 plus -2 is like 1 minus 2 is -1. So the image of C, that is C1, is 1, -1. So that is that. So we've been able to tackle a question. So that is all about translation. Let's take one last example, then we move on. All right, let's take this example. This one is using another method other than the one here. So here, the image of P, they are saying P prime is the image of the point P. So we have an image and we have a point by the translation vector V. So here the vector is not given. So the first question says find the vector what? V. And after that we will find another. So let's try the first one first. So always don't forget our image is still point plus our vector, right? But here we are finding what for the vector V. So here we make V the subject. So we can see our vector V equals, we are maintaining V. So I is there already. We are just taking P, so we negate P. So vector equal image minus what? The point. So let's write our point. Our point is what? Sorry, our image. The image is there, 8, -2 minus our point. Which one is the point? 5, 2. So our point is 5, 2. So we are finding the vector. 8 minus 5 is what? 3. -2 minus 2 is like you are owing 2. You are also in another 2. You are owing what? 4. So 3, -4. So this is our vector. So we are done with the vector. The next question says, find the coordinates of the point Q, which maps onto the point Q prime under V. So here, let me explain this question to you. Here, we have the image of Q, right? So we have the image of Q. Image of Q was given, right? Do you have the point? So we are finding the point Q. We don't know the point Q. But we are translating them under what? The vector V. But we know the vector V as what? 3, -4. So you just have to quote your, so it's the same method we are using. Our image is still point plus our vector, but here we are finding the point what k, so we are making p the subject. So if you want to find points, is what image that we have, our image, we have the image for q here minus the vector that we just identify that vector as being what 3, -4. So here our image is what 5, -2. That is our image minus our vector 3, -4. We know. So our point P is going to be 5 minus 3 is 2, -2 minus -4. So here's, let's look at something. It's like -2 minus -4, and you know negative times negative is positive, as usually saying again is positive. So here you are going to get our point is going to be 2, then you are going to get, this is going to be -2 plus what 4, this is going to turn to positive, so -2 plus 4, and this is also going to give us 2. So our point in coordinate form is what 2, 2. So do you get it? The question we were given what the image and a point, and we are able to find what the vector using the same point. And the next side of the question here gave us an image, and we are using the previous what vector. So if you get this vector wrong, you are going to get this k also wrong. So that is translation. So this is all that we will do for translation. So we are going to do another subtopic. And as I told you, there are 3 ways that we can change the position of an object without changing the shape, and that is what the rigid motion is about. Let's try reflection. So for reflection, there are so many methods. I would like you to just take note. So let's take the first formula, call it reflection in the x-axis, or we can say reflection in the line y equal 0. So we have something that at y-intercept x equal what 0. So if you have reflection in the line x-axis, so it's the same at x, we know that at x-intercept y is what 0. So if I draw a Cartesian equation, and here I'm indicating the x-intercept here. This is the line x where the x is meeting the y. See this side here, the value for y here would be what 0. So at x-intercept y is 0. So reflection in the line x-axis, reflection in the line x-axis is the same as where the y is what 0. Or alright, so here we see reflection in the x-axis, xy, this is the formula, maps to x -y, or we can say xy maps to x -y, same thing. Reflection in the line axis, reflection in the x-axis. Alright, the second one is reflection in the y-axis. So reflection in the y-axis, our xy maps to -xy. So just take note. So we are reflecting in the y-axis, there is something affecting x, we are negating x. But if you are reflecting in x-axis, something is also affecting what y, and that is what the negative. Let's take the next one, number 3, reflection in the line x equal k. So here we are saying the k is a scalar, it's a number, so it's a scalar. So we see our xy maps to here 2k minus x, then y is constant. Then our last one, we are going to solve more examples so you understand. So reflection in the line y equal k. So we have x, y maps to x 2k minus y. So this is what the formulas that you are going to use. These are the formulas you are going to use. So see, you have to take notes. You have to find ways to memorize all these points, right? You have to find ways. All right, look at this example. So here you have to find the image of the points 3, 4 by the reflection, and the first one says we are reflecting the line what x equals 0. And don't forget, I told you reflection in the line x equal what? 0 here. X equals 0. At x-intercept, y is always at first. So here, reflection in the x-axis. I told you reflection in the x-axis reflection in the y-axis at y-intercept, x is always what? 0. So here, reflection in the line y-axis is the same as reflection in the line x equal what? 0. So take note of the formulas that we are writing. So let's try the first one. We are going to solve two examples. So the first one, reflection in the line x equals 0 or y what axis. So quote your formula xy maps to reflection in the y axis. So we have what? Negative xy. Simple as that. Reflection in the y axis. So here, so we are taking which point? The point is 3, 4. So 3 and 4 will now change to what? Look at x. They are just negating x and maintaining y. So here, the image of the point. So let's say the point is P. So the image of this point is what? Negative 3 and what? 4. That is the first one. So the second one is a reflection in the line y equals 0. So line y equals 0 is same as x-axis. So here our x, y maps to, don't forget this is the same as this. I'm just changing it so that if you are writing exams and you use this method, sometimes you realize this one will like consume a lot of your working area. So if you do it like this, it minimizes space. So x, y maps to reflection in x-axis, x neg y. So here, the point 3, 4 will change to, you are maintaining x which is 3 and negating what? Y which is 4. So this is the answer. Now let's take the next one, reflection in the line x equal 2. Don't forget, here I told you reflection in the line x equal k. So here our k is now 2. So our reflection in the line x equal 2. We have our k, that is our constant. Our scalar, this the k has been what? 2. So you just have to write your formula xy maps to 2k minus x and what? Y. So let's continue it here. Alright, so your 3, 4, we are going to reflect it. You are finding the image. So 2 times k, our k is 2, minus our x, which is 3, right? And you are going to have our 4. So this is going to be 2 times 2 is what? 4 minus 3 and 4, right? So our 3 and 4 has been reflected to 4 minus 3 is what? 1, that is 4. Let me do it this way first. 1 and 4. So you can write it like this, 1 and what? 4. Obviously, you are just using the formula to just do it. Let's do the last one. Reflection in a line y equal what? K. That is y equal 1. So here our k value is what? 1. So reflection in line what? Y equal k. Where our k is what? So here where our k is 1. So reflection in that line xy, as you know, maps to what? X 2k minus y. So here your 3 4, you are changing it. So here our x is 3 and this is 2 times k. K is 1 minus the y is what? 4. So you are going to have the 3 4 is going to give us what? 3. You have 2 minus 4, right? So we are going to get 3 and negative 2. So the image of the point. So here the image of this point, the point 3 4, through the reflection in the line k equal 1 is giving us what? This is giving us what? 3 negative 2. I hope it's helpful. So this is all about reflection, and these are all the questions that they can ask you in reflection. So reflection in the line x as it, you have to know the formula at x as it what? You know that y is always 0. It's always the same as the line y equals 0. So you have to know the formula. So let's take another example, just one example, then we finalize rotation. So here you are just going to reflect the points. So sometimes they'll give you a question that reflects negative 2 5 in the, here let's take only one, okay, 2, line y equal negative 2 and I x equal negative 3. Don't confuse yourself when they say in the line x equals 0. When the scalar here, the number constant value is 0, where the line x equals 0 is reflection in the what? Y-axis. But if this side we are having a number, whether being a positive or what? A negative integer, know that that one uses a different approach from the one we have been dealing with. So let because of that, let me just add 1 to it. X equal, let's say 0 before I'll bring the x equal negative 3. So the first one, reflection in the line x y equal k is what? X 2k minus y, and you are aware. So here the point is what? Negative 2 and 5. So x is negative 2, we are having 2k, k is what? Negative 2 minus y, which is 5, right? I just want us to do it this side. So negative 2, 2 times negative 2 is negative 4, negative 5. So this one is going to give us what? Negative 2, negative 9. Or you can write it negative 2, negative 9 here. So this is the answer for the first one, reflection in the line y equal what? Negative 2. Good. I hope you are following. Let's try the next one here. Reflection in the line x equals 0. You know x equals 0 is what? Y-axis. And at y-axis, xy maps to what? Y-axis, negative x and what? Y. So here the point negative 2, 5, you are going to change, you are negating what? Negative 2 here. You are going to negate this and 5. So the thing is already negative. So if you negate another negative, it becomes what? Positive. So the second one is 2, 5. You can write it 2 and what? 5. So that is that. Make sure you check your signs very well. The negative, negating another negative, becoming positive, and the rest. So reflection in the line x equal negative 3. As I told you, this is not 0, so we are going to use this method. 2k minus x and our y. So our k is what? Negative 3. So our point negative 2, 5 is now going to change to 2 times the k is what? Negative 3 minus x is negative 2. Then this is 5. So see, 2 times, this is negative 6. 2 times negative 3. And we have minus. You see, it is minus. And the x is still negative. Negative times negative becomes what? Positive. So you are going to have 5 and what? Negative 4. Which is 5, negative 4. So that is all under what? Reflection. I'll be sending you more assignments on this topic that you have to solve you have to try your hands on them. You have to be solving more of the assignments I'll be giving to you. So I'll be uploading them for you to just do it. So let's try the last one. Rotation. So for rotation, we are going to rotate something. I have a couple of things here with me. X, negative x, y, negative y. So see, let's write on my paper. I have x, negative x, I have y, negative y. So here, so you are going to rotate it. Rotate either clockwise. So we have clockwise here as the clock moves, that is clockwise, and anti-clockwise or the anti-clockwise, that is in the opposite direction of the clock. So here, that was what goes this side. So here, we are going to write the formula. So we have rotation. Let me just use this to give you the formula. Then when you finish, I'll give you the rest. So here, it is like this. Hope you can see. So here we are rotating. Let's rotate 90 degrees clockwise. So we are just rotating 90, and you know here, this is 90, this is 90, here is 180, this side is 270, and here is where we start from 0, or we also end at 360. So take note. So here, we are rotating from y to 90 degrees. So we are moving from 0 to 90. So here, just 1, we are turning 1. So here, the formula is what? X, y. So we start from x. This is x, as you can see, and this is what? Y. So we have x and y. So we are turning it. We are turning just 90 degrees we have. So which one is showing? You see the position of x has changed. The position of x is now y. Go to where the y was, and that one is negative x. So if you rotate a point clockwise 90 degrees, it is what? The position will change x, y. Here the y is leading and the negative x will come down. That is how we do it. Now let's try something. 90 degrees clockwise is the same as 270 degrees anti-clockwise. So it's the same as 270 degrees anti-clockwise. Let's see something here. Let's see something. It was here. Yes. X, y. We change it 1. It becomes what? Y negative x. Now let's go back. We are changing 270 anti-clockwise. We are going back 3 times. So 270. So here, this x, y. So from here, it is on y, right? Taking it, so we start x, y. So we always read it from here. So we are going 1. This is 90 degrees anti-clockwise. We've moved 90 degrees anti-clockwise. From here to here is 90 degrees anti-clockwise. Let's go another one. 180 degrees anti-clockwise. Yaku 2. We are here. Maybe you are confused. Look at. where this is starting from. Look at where y is. We are moving y 3 times. So the first one, xy, 1, the y has come to 90. That's 90 degrees anti-clockwise. 2, the y has come here. That is the second one, 180 degrees anti-clockwise. Then 3, 270 what? Anti-clockwise. Then let's go and check it. We are reading. I told you read from the x-axis to what? The y-axis. So x and y. So the x is what? What is showing? We can see y is still showing here. And what is the x? So 270 degrees anti-clockwise is the same as 90 degrees clockwise. That's the formula. Now for 180 clockwise is the same as what? Anti-clockwise. The same as 180 degrees anti-clockwise. They are same. They are same. So here we are just doing whether we go forward or we go down, you get the same thing because it's just half of it. So here x and y, you are going 1, 1. So we have y negative x, that's 90 degrees clockwise. You are going good. The second one is what? 180. So we are having the x, y, we are having negative x and what? Negative y. So that is that for 180. So now let's try the last one. 270 degrees clockwise is the same as 90 degrees anti-clockwise, as we use this to show. So in your exams room, if you cannot get a paper like this to rotate, then it is better you memorize everything in your head. So here 270 degrees clockwise, you are going 270 clockwise. So xy, xy, you are going 190, 180, then the next what? 270. So what are we having? We are having negative y, and what is on top is positive x. So that is that. So all the formulas for rotation is what we've been able to just cover. So it's just 90 degrees clockwise or 270 anti-clockwise, and 180 degrees whether clockwise or anti-clockwise, and you have 270 degrees clockwise, which is same as 90 degrees anti-clockwise. So let's a quick one. Let's try that. We are just going back, just one. 90 degrees anti-clockwise, 1. We're having negative y, x, the same thing. So that is that. So let's quickly try one example for this, and let's call it a day. Okay, we have this triangle ABC, and the question is we have to rotate triangle ABC through. So the first one is 90 degrees clockwise. 90 degrees clockwise. So you quote your formula, xy maps to what? Y negative x. So you say A, so you just write your formula, xy maps to y negative x here. So excuse me, if you take A to negative 2, negative 1 will now become C. X, Y. So here, which one is leading? Y is now leading. So the Y here is negative 1. So we're going to write negative 1, which is Y. Then the X, we are negating the X. So here the X is negative. Let me do it this way so that my student will not be confused. X, Y. As it is here. 2 and negative 1. So here. So check something. Here, Y is now leading. Y is here. So here, we can say that X equals what? Negative 2 and Y equals negative 1. If you compare this to this one. So here we are writing Y, which is negative 1. and our x is what? The first it was negative x. So we see our x is negative what? 2. And they are saying it is negative of what? X. So negative of negative what? X. So this negative times negative is going to be positive. So the image is going to be negative 1 and what? 2. That is nege. Do you get it? Let's try B and the other. Maybe by the time you finish, you'll get it. So for B, you know for B is what? Our x, y maps to y negative x. So our B is what? 1, negative 1. And it's going to be, so here our x is 1 and our y is also what? Negative 1. So y is really negative 1, negative x, so it's negative 1. So we have x is 1, but we are negating it, so we are going to get negative 1. So the image of B is negative 1, negative 1, right? Let's try C. So C is what? 1, 1, right? So we know that if you compare with this one, our x is 1 and our y is also 1. So here is just y leading, which is 1, and our x negative 1, right? So the image of C is 1, negative 1. So we are done. So if they didn't ask you for this, okay, I'll give you an assignment. Your assignment is rotate the point through 90 degrees. No, let me give you 270 degrees anti-clockwise. So this one is going to be your assignment. So thank you for watching. In our next video, we are going to take a complete question on rigid motion. That one, we are going to take our graph books, then we will plot all the points, all the examples that we've tried. We will just plot them on our graph book. So until we meet again, let's call it a day.